I didn't plan to name this video like this, but as I was writing the script for it, I had an epiphany. There's this idea that you can play any pop song with just 4 chords. And today we're going to see how you can get productive with functional programming by learning just 4 functions. Let's get right to it. Hey, Vlad here from Dependencies.com. Welcome to another video. If you're new here, you should know that this is mostly a Scala channel, and I've already made countless Scala-related tutorials, including the ones about functional programming. This one, however, is not a tutorial, and I'm also not going to make you wait until the end of the video to reveal these 4 functions. We're talking about map, flat map, traverse, and flat traverse. If you're using Zio, traverse is called for each, and it's defined on the Zio companion object. Flat traverse doesn't exist, so you basically have to call for each and then flatten yourself. You can define it on your own, or you can use something like cats interrupt. If you're comfortable with these, you should be able to write a typical backend for a web application where you smash some APIs together that return some sort of I/O. If you're new to these functions, this video might be a little bit tough to follow, but I'm going to include the link down in the description to the GitHub repo with all the code. I made sure not to use any libraries, so please feel free to clone it, mess around with it until you understand exactly what is there. A very easy way to support this channel is to give it a like so that YouTube can push it to more viewers. Thanks. I would like to welcome our new sponsors, Scala Jobs, as well as Rust Jobs. You can find all the links in the description below. This video is also brought to you by awesome people like yourself who support me on Patreon. Your contributions allow me to pay for a video editor who frees some of my time, which I then again choose to spend with you, whether it's during live streams or answering your questions on Discord. A big shout out to my highest tier patron, Brad Albu. Or Patreon. I never know how to say it. I genuinely never know how to say it. I used to say patrons. If it's one patron, if it's still Patreon. Alright, now initially I wanted to make this video about the fact that functional programming can be very abstract, and as such it poses challenges for beginners. In particular, there's this annoying phrase that functional programmers like to throw around. It goes along the lines of, FP is easier to reason about. So I wanted to make a video to explain precisely why that is, and also why it totally makes sense that you as a beginner disagree. And as already mentioned, while I was working on the script, I realized that these 4 functions get you pretty far in the functional world. Now let me show you some code before I get to the point that I'm trying to make. It's not a lot of code, but some parts are a bit advanced, so don't get discouraged if you don't understand a thing or two. As already mentioned, the entire code is on GitHub, but this video is not about the Scala syntactic particularities. It's much bigger than that. It's a Scala 3 code base, by the way. So it's pretty much a hello world app, and there are 4 functions. All of them do exactly the same thing. It's just that they're implemented differently. And it's simple code. We give it a user ID, and it tries to find the zip code of that user, and based on the zip code, it tries to find the city. And in the first 2 scenarios, it doesn't, like this one doesn't find the user, this one doesn't find the zip code, and in those 2 cases, it actually finds both. Okay, and as I already mentioned, we're running this thing 4 times. It's like 4 different programs, but technically they're all the same. The implementation is just different. All right, so let me show you some code. It's over here. So as already mentioned, this is the main. As you can see, there's only like 7 files. This entire code is going to be on GitHub. I didn't use any libraries. Okay. We're starting with a couple of user IDs. I use some negative IDs to just, control in which branch the code is going to flow. And we have some service. Scala allows for top-level definitions. So there's a file called di over there, and inside of it, there's a val service. And it has a method called getCityName 1, 2, 3, 4. We'll give it one of these user IDs. As you can see over here, we're going through all of the user IDs. So one by one, we pass it along to this method, and it calculates a so-called functional description of a program. So it actually doesn't do anything until we call unsafe run. Now, this video is not necessarily about I/O or monads, but it is a bit related. I have videos about that, so you might want to check it out. Okay. Then we see a couple of hyphens, and we run all of those 4. Okay. The next thing I'm going to show you is some types. There's a file called types.scala, as you can see, just like 2 classes, 2 data structures. User and a city. The user has an ID and a zip code. City has a zip code and the name of the city. So we kind of, we go through the ID, through the zip code, arrive at the name. The type aliases are just here for readability reasons. They're not actually preventing you from passing a zip code as a user ID, for example. Okay. Now, the next thing I'm going to show you are the dependencies over here. This is just a trait. We can find the user by the ID. It gives us an I/O. If you're not familiar with I/O, think about it as a future or some asynchronous thingy. And then it returns a maybe. This is my own implementation of option because I didn't want to depend on libraries, because I wanted you to be able to go to the code and change it. So it's an I/O of maybe of a user. So maybe you'll find the user. maybe we won't find the user, then we'll get the zip code out of it, and then we'll call this method find city, put the zip code in here, and then we're going to get an IO of maybe a city or maybe not. All right. This is a dependency injection part with this val service. It's the one that we have over here. So we're creating a new service. In Scala 3, you don't have to say new service. And then we are passing along new dependencies, right? So this is the implementation of find user and find city. The actual implementation is not really that important. I just, create a bit of logic over here so that it can make sure that it goes through all the branches, right? So maybe it's not going to find the user. Maybe it will find the user with a negative zip code. Maybe it will find the user with a positive zip code. And maybe it will find a user with a zip code that is bigger than 1000, okay? And then when it arrives at find city, it's going to make sure, well, if the zip code is under 0, then it's nothing. Under 1000, then it's Tokyo, and otherwise it's going to be New York, right? So basically I made sure that it goes through all of the branches, okay? But none of that stuff is actually important. This video is not about any of that stuff. This video is more about things like IO and maybe. So if you go into IO, this is this data structure that just captures a so-called thunk. A thunk is a function that has an empty parameter list and then it just returns something. The goal of IO is to delay some computation so that you can manipulate descriptions of programs and stay within this magical world where the substitution model for procedural application is not broken. And so you never run these functions, you just compose them all together. And then at the end of the world, which is the main method, we call unsafe run, as you have seen over here, right? So this is the only one time where these functions are called. Everybody else calls functions like map and flat map that are designed to just compose IOs together, right? So as you can see, flat map will call unsafe run for you. You technically never have to call it yourself. But as I already mentioned, this video is not necessarily about IO. It's not about monads. It's actually rather about pattern matching. Okay, so this is where we're going to have a look at maybe, which is my implementation of option. The names are coming from Haskell, and so it also has map and flat map, but it also has these two functions, traverse and flat traverse. You don't need to look at them in depth. You don't need to fully understand what they're doing. This is not what this video is about. This video is about the fact that all of them are implemented in terms of fold, and fold basically hides pattern matching. So essentially, all of them are implemented by using pattern matching. And it has to do with the fact that maybe is an algebraic data type, right? It's a type that has two forms. It maybe can either be a just A or it can be nothing. And therefore, no matter what you do with it, you have to pattern match. And this is going to be important in just a moment. All right, let's have a look at service. So remember, we have a val service we call get city name 1234, which is why we have 1, 2, 3, 4. Okay, they all do exactly the same thing. They just do it in different ways. Okay, we're going to start with the one that is going to be easy for you to read as a beginner. However, as soon as you get some more experience in functional programming, you will actually start finding it harder to reason about. And this is exactly what this video about. I'm going to explain it to you why it's going to start feel like this. All right. So if I open this, you're going to see that there's going to be a pattern match. Essentially, this solution is not going to use any of these helpers. It's not going to use map and flat map over here. It's not going to use fold map, flat map, traverse, and flat traverse. Okay. It's basically going to do everything on its own, pattern matching, super easy to read. So user ID comes in. We need to produce some sort of IO that maybe gives the name of the city back, right? Because it's called get city name. Okay. So if I open this one, we're going to see, okay, well, we need to produce an IO. Therefore, we call IO delay. Then we have these dependencies over here. We call find user. We pass in user ID. It gives us only a description. And because we're not using these helpers, we need to call unsafe run. Now this finally returns a maybe of a user. So we call match on it. If it's nothing, we return nothing, right? So we're returning IO of nothing. If we actually do find the user, well, then we take the zip code. We try to find the city. Again, this is just a description of a program that would find the city. So we call unsafe run. Therefore, the return type of unsafe run is a maybe city. We match on it again. If it's nothing, then again, it's an IO of nothing, the result type over here. And if we actually do find the city, well, then we just get its name, wrap it again in just, and we're done. Nice and simple. Why do advanced functional programmers find this harder to reason about? And before we get to answer this question, let's actually have a look at the implementation that advanced functional programmers, and by the way, not necessarily advanced, it's just like people who are like a little bit more familiar with it would prefer. And it looks like this. As a beginner, this code is more advanced. It's more complicated because there are new keywords like for, there is yield, there are potentially unfamiliar functions like flat traverse, there's a function called map, there are also these weird arrows. Now, this video is technically not about for comprehensions. I have a video about for comprehensions. You might want to check it out. If you're not familiar, for comprehensions essentially desugar to function calls of flat map, and in the end, the yield desugars to map. But this is not what this video is about. And also, I made sure to use a more advanced example where we use flat traverse. So we have to call it, we cannot just use a full comprehension, okay? Now, these two are somewhere in the middle between this solution and between this solution. So this is roughly what this full comprehension desugars to. So as you can see, we're finding the user, but then instead of calling unsafe run, we're calling flat map, and flat map will call unsafe run for us, so we don't have to do this, okay? So flat map wants a function that would take a user and produce, in this case, maybe string. So maybe user is now, well, a maybe user. We take it, we call flat traverse on it. No matter what it doesn't really matter right now, okay? So, but essentially, anytime you call, anytime you're dealing with IO of something, whenever you have this something sort of like naked, not wrapped into IO, and usually it would be an option or some sort of list, this is when you need to call traverse or flat traverse. We're calling flat traverse because the function over here also returned a maybe, and therefore we want it to be flattened. Flat traverse so that we can get the zip code out of it. And then we're calling find the city. This whole thing over here is still in IO, so we're calling map. Maybe city comes in. We're doing maybe city map because maybe city is, well, it's a maybe city. So we do the map, and I made sure not to use this underscore syntax because this video is for beginners. So I know it's already going to be complicated enough to read this. This one is also similar. Notice how we call flat traverse over here, and then when we're done, we're calling flat map. We're calling map, I'm sorry. In this one, we're calling flat traverse, and inside of it, we're calling map. Okay, and we're going to discuss why I included exactly these different variations in just a moment. The point of this video is essentially to explain to you why the first three versions are somehow better than the fourth version. Even though there are a couple of things that are kind of obvious, like you're calling a method called unsafe run. Maybe it is unsafe to call it. Maybe this is the reason why it's called like this, right? But again, this video is not exactly about this. This video is about the fact that, and as already mentioned, everything you do with a maybe involves a pattern match, so to say, which means that if you have some relatively advanced code to write, everything will look like pattern matching, right? And therefore, if I want to reason about it, I need to actually read every single character of what you wrote. And potentially you have to do it as well, or technically the future you. You write a big pattern match, and it's very, very custom. So if you look at it 1 week later, you need to go through every single branch, through every single character to understand what it actually does, because it is custom. Now, technically, all code we write is custom, but pattern matching is very low level, so to say. This is when functional programmers say something like, well, I want to say what to do. I don't want to say how to do it. So pattern matching is how to do it. So this means that if I look at this code over here, for example, right, I need to make sure that you didn't include something fancy in there, right? Something like maybe you went over here and you went like this and you said, well, if the user ID equals 1337, then I'm not even going to look for the city. I'm just going to create a just, okay? And I'm going to put a console.green in there plus matrix. So now all of a sudden we don't live in Tokyo, we don't live in New York, we actually live in the matrix. This should be two equal signs over here, right? And so if I look at the code and all of a sudden we live in the matrix, right? So because you have written this very custom code, I need to make sure that you did not accidentally include something like this. Here's another example. I'm going to remove this. I'm going to go to our dependencies, right? So for example, into the implementation of find city. And I'm going to do something that usually I wouldn't do. But as you can see over here, we're deleting something, right? So it's totally safe to go in here and say, well, I'm going to say console.read. I'm going to say finding the city, okay? Plus console.reset, okay? So if I look at it right now, like obviously before we finding the city, we see the print line, finding the city, finding the city, finding the city. Okay. Over here, we don't see it before the nothing because we didn't find the user, but that's not the point. Okay. So let's say that you went over here and because, I'm sorry, over here, and because you wrote this whole thing yourself, you made a mistake. Instead of doing IO delay over here, you went over here, right? And you went like this, IO dot delay, nothing, right? We just need to produce an IO in every branch. Okay. So IO delay, nothing over here. IO delay, nothing over here. Let's say you did it like this. Everything compiles, but now the code behaves differently if we go over here, and maybe I should have shown it to you before. Over here, we're going to just calculate the description, but we're not going to run the program. Okay? Now look how it looks like. Okay? We're still finding the city. Okay? If I revert this code over here in the service, if I go back a little bit like that, then nothing is happening. Okay. So because you were explaining exactly how to run some code, your space for bugs was much bigger. Now, functional programming is not bulletproof, but still. So when you get experience with functional programming, you will start preferring using these very specific building blocks that know how to do things and you kind of don't care about it, but you know them very well. They're very precisely defined. They're even mathematically proven sometimes, most of the times actually. And so you have this almost like a guarantee. You have this warm and fuzzy feeling when you need to change the code. For example, if I go up there over here, I know because I know exactly how these tiny building blocks work because they're very general. They're very general, and so you use them all the time with all the time with all kinds of types. For example, over here we have a maybe user that we call flat traverse. User comes in, dependency find city user.zip code. Okay, so technically over here we don't need the user, we just need the zip code. So I have a guarantee that what I'm doing right now is not going to break anything. Okay, so this code basically says, okay, well, if the user comes in, well, then let's take the zip code. Therefore, when we call flat traverse, this over here is not going to be the user. This is going to be the zip code. Okay, and because this is the zip code, I go over here and I just use the zip code like this. Okay, as you can see, the code behaves the same. Let me actually go real quick into the dependencies, find city implementation, remove this print line. So as you can see, I forgot to go to the main and actually undo what I did over here, right? Which is that. Okay. So as you can see, this code still behaves the same. And so now I can keep going, right? I can go into the service and I can say, oh, okay, well, this lambda over here that is inside of all of these brands, it has exactly the same signature as find city. So I can use the ADA expansion to do something like this. Okay, I can find as E, delete around parameters, right? So the compiler will do this thing for me. And now this whole thing fits into one line. I can go like this, okay? And so now I safely refactor this code without any fear. And it got a little bit shorter, right? So it's hard to see. There we go. It got a little bit shorter. And I could only do this because these building blocks provide me these guarantees that I can do that. So I decided to make this video because I heard this very often that, that when you get into functional programming, you find code like this easier. And especially when you get to Scala and you see pattern matching for the first time, you're like, oh my God, I want to pattern match all the things. But if you do that, most of your code is going to be pattern matching. And therefore, you will have to inspect it in extreme depth to be sure that what it does is actually exactly what you think it does. Now, I'm going to explain a couple of these functions, but I'm not going to go into depth. Okay, I just want to give you like a little bit of an extra information. Okay, for example, look at this code over here. This last line, pretty much. Okay, so we're starting over here with a maybe city, right? So unsafe run is a function that, if you call it without any parameters, which is exactly what we do, it will return a maybe city. Okay, we pattern match on a maybe city. If it's nothing, it stays nothing. If it's just a city, then we apply some sort of function to the city. In this case, we're just getting at the name, and then we make sure to wrap it back into adjust. Okay, so again, pattern match. We apply some transformation if it's adjust. And after we're done with the transformation, we wrap it back into adjust. Okay, so this is a function called map. Okay, so for example, if we look at this one, As you can see, the building blocks are over there. So if I jump into map, we should see exactly that. We should see the pattern match. If it's nothing, it should stay nothing. If it's adjust, it's going to apply some function to the value, and then it's going to wrap it back into adjust. Let's jump in there. It actually calls a fold, but fold is just pattern matching. As you can see, you give it two thingies. One is a function. In case it's adjust, the function will be applied. Another one is a by name parameter. In case it's a nothing, we get out the nothing. Okay, so this is exactly what happens. We're saying, okay, well, if it's a nothing, it should stay nothing. If it's adjust, then apply some transformation to the A and wrap it back into adjust. In fact, maps come from a category theory concept called functors. And we're not going to go into depth into category theory over here, but the purpose of a functor is to preserve structure. It basically means that if you start with a maybe, no matter which transformation you do to a maybe, right? So if you call map, if you ask the functor to do this transformation for you, it will guarantee that what comes out of this computation is still going to be a maybe. Okay, so if you call map on a maybe comes out. If you call map on a list comes out. You might start with a list of int, and a list of string might come out, but it's still going to be a list. By the way, the Scala collections library mixes some concepts in there, so you have some subtyping and stuff. So occasionally, when you have a range and you take every element, you map it to a string, then the resulting type is not going to be a range anymore. It's going to be an index sequence or something like this, right? But the idea is the same. So I created this repository for you to be able to clone it, understand exactly what these functions are doing, mess around with them, maybe define your own. You could define your own list, and you can define exactly all of these functions. Trust me, they're going to work, because a list is also just an algebraic data type. You're going to have a case for an empty list. You're going to have a case with a head and a tail. It's going to look very similar. By the way, this is the Scala 3 syntax for creating algebraic data types. And this is also a Scala 3 feature. We're exporting maybe dot star. So we're exporting everything that is in the companion object of maybe, which is just, and nothing. And therefore, in other places, we don't have to do maybe dot just. We can just do just. Okay. So without it, the compiler will tell us over here, hey, like these things don't exist. And so we would be forced to do maybe dot. Okay. So, yeah, there you go. So comment out, and there you go. Everything is green. So clone this repo, mess around with the stuff, understand what these, look, all of them are one-liners. I admit that something like traverse is not easy to read, but if you spend a little bit of time with them, insert a bunch of print lines in there, and please stop using pattern matching all the time. Because if you don't use these building blocks, all your code will look like a gigantic pattern match, and it's too custom. So in order to reason about it, which was the whole purpose of this video, you need to read every line, every character. Again, check out the link in the description of the video to the repository, clone it, mess around with it. I hope you liked this one. Check out the previous one, and I'm going to see you in the next one. For now, as always, it's Vlad from Dependencies.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you wish to support tech education, please consider doing so on Patreon or on GitHub sponsors, and watch my videos before everyone else. And most importantly, take care.